In this video, we are going to look at a key concept in IB Maths exams, which is radians, length of an arc, and an area of a sector. So, we're probably familiar with a circle having 360 degrees. When we first learnt angles, we learnt degrees, but there is another measurement of an angle which isn't degrees, and it's called a radian, or radians. And in a circle, there are 2 pi radians. 2 pi radians, and this is the same as 360 degrees. So this is just 2 different ways of measuring an angle. Now radians are actually a lot older than degrees, and they actually make a lot more sense when we use sectors of circles. So not a full circle, maybe some sort of sector, and we want to find the arc length and the area of this sector. So let's do a few examples. If we know we have a sector of a circle, I'm just going to draw one here, where the radius of this sector, which will be from the middle out, let's say is 10, and the angle here we don't know, let's currently say this is theta, and we know that the outside arc length, this L, will be 20, and we'll give these centimeters and centimeters. Well, in fact, we can find out what theta is very quickly in radians, because all theta is going to be the arc length divided by the radius. So theta is just going to be the arc length over the radius, which will be 20 over 10, which is 2. And if you have a look at this first formula up here, the length of an arc, this is just the same equation slightly rearranged. If we divide the r underneath, theta in radians is just the length over the radius. So really, a long time ago, it was a lot better to use radians because we could quickly work out, if the arc length is 3 times bigger than the radius, it would be 3 radians, or 4 times bigger, 4 radians, and so on and so on. And in a full circle, the circumference of the full circle is 6.28 times bigger than the radius, which is 2 pi, which is why there's 2 pi in a full circle. So that's what a radian is, and that's kind of why we used to use it. Now, in the IB maths questions, you're going to get a lot of sectors, and you might actually be given theta. So let's just say this is now 1.8 radians. Radians, you might see rad or a little c at the top there. So 1.8 radians, and we want to find out the arc length. And if this is the case, we just use the formula given in our formula booklet. The arc length will be theta multiplied by r, and we need to make sure theta is in radians. So our arc length, which is this distance here, will just be 10 times 1.8. 1.8 times 10, which would be 18 centimeters. Okay, now in these questions, you'll also be asked to find the area, and the area of a sector formula is this one here. This wasn't too bad, it's very similar to the one above, but it's now a half times theta r squared, where theta needs to be in radians. So if we had this question here, and we wanted to find the area of this sector, which would be this bit here, all of that shaded region, we can just go, the area is a half times theta, which needs to be in radians, multiplied by 10 squared. So we'd have a half times 1.8 times 100. And this would be 180 times a half, so 90 centimeters squared. Okay, so that's a bit of an introduction. The length of an arc, we can use this formula. The area of an arc, this formula here. Theta is in radians, and hopefully now you know what a radian is. It's a measurement of the angle inside of any angle really, but it's different to degrees. It's all to do with lengths of arcs divided by its radius. Okay, good luck.